My name is Victor Ciura, and I'm a senior software engineer at Cafion, and I'm working on the Advanced Installer team. I've been working on the Advanced Installer for over a decade now, working with my team on improving the repackaging and virtualization technologies in Advanced Installer, helping our clients migrate their legacy Win32 applications to the modern Windows Store format, UWP, Apex files. So we're in the packaging and deployment business. Why am I here? Well, subtitle for my talk would be 14-year-old code base under active development, 2.5 million lines of C++ code, a few brave nerves, 2 powerful tools and 1 hot summer, or how we managed to clang-tidy our whole code base while still maintaining our release cycle. So if this is something of interest to you, and I'm guessing it is since you're here, this talk is for you. A little bit of a context so you can appropriately gauge the scale and impact of these transformations for us and maybe compare that with your projects. Advanced Installer is a Windows installer authoring tool. It's like an IDE. It's a big umbrella project for many tools, and it helps developers and IT pros create MSI, EXE, AppV, and Apex packages. It's a 14-year-old code base, like I said, about 2.5 million lines of C++ code, 130 Visual Studio projects that include EXEs, DLLs, static libraries. We build everything with Visual Studio 2017 now. We're on a monthly release cycle on about 3-week sprints. We do Windows-only deployment, so no cross-platform for us. And we have strong Windows SDK dependencies, as you might imagine, because of our application domain. A little disclaimer, this talk is not about Clang versus Visual Studio. We're a Windows-only development team, and we're going to continue being that way. So we plan on using both Visual Studio 2017 and Clang tooling on the side to help and improve our coding. This is more like a case study talk about our experience and the tools we developed. So I think it's appropriate to give you a timeline so you can get a feel for the scale and how long this took and how you might adapt this workflow for your team and projects. It all started a year ago with Clang format. In September of last year, we started thinking about adopting Clang format for our project, and we experimented with various configs. We established internal rules, exceptions. As you might imagine, we had serious debates over the style guidance. And about a year ago, we did the big reformat and a big push in our code repository with all the code reformatted with our custom style. And we've been using this as a workflow for over a year now, using basically auto format on save from Visual Studio. I highly recommend that you give it a try. It might be painful at start, but it's definitely worth it. I cannot imagine living without Clang format going forward. Building on the success of Clang format adoption within the team, we gained courage to experiment with other Clang tools like clang-tidy. So as opposed to Clang format, using other Clang tools, you actually need to be able to compile your code base with Clang. Clang format just needs to have some semi-valid syntax to work. But clang-tidy needs to be able to properly compile your code base, at least at the front-end level. So we, as you might imagine, we found several compatibility issues between a Visual Studio compiler and Clang 4.0 that we started with. And just a note, we were already on the highest warning levels with Visual Studio using W4 and treating all warnings as errors. So if your compiler will allow you to use easily non-standard extensions, developers will use them, as you might imagine. And we started fixing all non-conformant code. And yes, we did need some automation in doing that. Some of the transformations were quite mechanical in nature. And we set ourselves a goal to be able to do large-scale refactorings with clang-tidy, modernize, and readability modules, as well as running static analysis with clang-tidy. And yes, I know Visual Studio has a static analyzer, and yes, it does have a CPP code guideline checker, but you can never have enough tools and checks in your life. So more is better. Just a few examples of fixes we've needed to do. For example, delete with a non-virtual destructor, an overload that was a mistake that hides a virtual function, loop variable that was incremented twice by mistake, not on purpose. So a few pessimizing moves that inhibited return value optimizations. Just a bit of a flavor. Lots of member initializer lists that didn't match the member declarations within the class definition. This is a big one that we had to automate and fix. A frequent offender, 2 user-defined conversions that Visual Studio happily applies. For example, this one bothered us quite a bit. Conversion from char array to standard string, and from standard string to some other user-defined type with the conversion constructor. Coming back to the timeline, we started playing with Clang on Windows, back then 3.9, in January. First commits in fixing Clang errors and warnings. We started with a crude automation attempt by creating a batch file, and you're going to see that later on. But we soon ran into limitations on using that approach, and we developed a more powerful PowerShell script to help us with the fixing workflow. About in March, our PowerShell scripts gains the ability to run clang-tidy as well. So we did the first experiments with clang-tidy just to get the feel for it on some selected parts of our code. And by April, we were able to compile our whole code base with Clang 3.9 with some default warnings turned off, to be fair. So about 3 months' time with a part-time effort. This was not a full-time job. We were doing this live on our master branch while developing features and improvements in our commercial product. So this was like started more like a hobby project for us, and it was definitely a part-time effort. So it can be done. As soon as we achieved cross-compiler compatibility between Visual Studio and Clang, we created the Jenkins job for Clang build. We use Jenkins for build automation for our project. So we basically want to make sure that we don't have any regressions because we worked hard in achieving compatibility. So every source control commit triggers a Clang build on our build servers. By May, we made great improvements to our PowerShell script. It gained the ability to handle precompiled headers, parallel compilation. Initially, our scripts were only able to run overnight. As you might imagine, due to the scale of the code base, it took a very long time. So we cut that time seriously. Gate support for project filters, SDK versioning, and more. During the summer, we did more experiments with clang-tidy, with better coverage on our code base to learn more on how to use the tool and how to understand its reports and transformations and impact on our code base. And by June, we upgraded from Visual Studio 2015 to 2017. This is relevant for Clang because we also needed to update our Clang scripts to reference new include paths and SDK dependencies. And we started work on a custom Clang-based refactoring tool built on top of libtooling that helped us do some code transformations that were quite big and mechanical. And those were something that was something that we definitely couldn't do with simple grep replace or regular expressions. So we upgraded to Clang 4 and fixed some of the new warnings, and we got courageous and started to tackle warnings issued by WAL in our source code. And we made extensive code transformations using our custom-built libtooling tools. By end of August, we were able to compile our whole code base with all Clang warnings enabled, not extra. And we started working on Clang Power Tools extension for Visual Studio to help with the developer workflow, not just with continuous integration. In August, we did the first large-scale refactorings. We started with using nullputter, range-based for loops conversions, and other modernize and readability checks. Again, we got a little courageous, adventurous, and we started fixing W extra warnings. That's still in progress. Lots more to go there. A lot of uninitialized field members in aggregate structures. We're going to definitely go that path going forward. We upgraded to LLVM 5 and fixed new warnings coming in from this upgrade, most of them related to Lambda captures. And in September of this year, we open sourced our Clang Power Tools project and published our free Clang Power Tools extension in the Visual Studio Marketplace, and introduced this project to the C++ community in September at CPPCon. And here we are. Some large-scale refactorings we performed, just to make you acquainted with them. I will go into some details on some of them. Modernize use nullputter. This is a no-brainer. Loop convert, transforming your for loops in range for loops. Use override. This was quite a big one, and with a beneficial impact, I would say. Readability, remove redundant C string from a standard string. Use and place instead of pushbacks when appropriate. Use auto, again, a controversial one, but we embraced it. Use make shared and make unique. Equals default, equals delete. This is a big one as well. A big transformation, drastically reduced boilerplate code. Default member initializers, removing redundant member initializers, in-class initializers. We embraced the pass-by-value pattern for sync arguments. Modernize return by brace initialization. UseUsing, replacing type defs with using declarations. Readability improvements regarding redundant string initialization and string construction. Inefficient string compares, inefficient algorithm usages with regards to iterators, and of course, CPP core guideline checks. Some cautionary tales, issues that we found. For example, readability, remove redundant string C underscore. Somebody was careful enough to leave a comment there to warn about this issue. For example, in this case, a string was used as a buffer. You might argue that's not appropriate, but that was the code. So removing that C string call was definitely a bug. We caught that in time. Make shared, make unique. Another example, can anybody spot the problem here? Minus is the old code, plus is what the transformation did. Can anybody spot the issue here? Yeah? Yeah, exactly. Type definition for make unique should be byte square brackets. Okay. Use auto, something we embraced and we love it, but it left us with some unused type defs that were used as iterators. and we had to clean up those by hand, unfortunately. Range-based for loops conversions left us with some unused values, like iterator ranges, like in this example, first and last remained orphan and used that loop counter. This was a frequent issue that we had to clean up by hand. UseUsing is a transformation that sounds trivial, and we had some surprises there. One example being function pointer definitions. As you might imagine, as Windows developers, when interacting with Windows APIs, we need to use standard calling convention. That's Win API there, macro there. So Tidy did some weird transformation there. So we had to fix those by hand. The correct version is the last one. This is a quite ugly one. UseUsing, aside from being incomplete, it actually missed a lot of type defs. For template argument types, it actually replaced the concrete type used, one of them, I guess, instead of maintaining the template argument type. Simple example here. We actually needed that type def because we referenced that template argument type in some derived class. So it actually replaced key type with standard string. That was an unexpected surprise. How did we achieve all that? Well, using tools. First of all, our custom-developed PowerShell script, our custom-developed transformation tool based on lib tooling, and of course, the Visual Studio extension that we developed. I'm up here, but I have to give a shout out to my buddies that helped a lot in this regard. My colleague Gabriel is sitting right there. He's the PowerShell wizard that's behind this tool. My colleagues Ionuț and Alex working on the Visual Studio extension, and my colleague Mihai working on the custom lib tooling project, and of course lots of other teammates that helped in fixing warnings and errors from Clang. Like I said, we started simple. This is how it started, with a simple batch file. You can probably parse it in your head. We soon ran into limitations on using this approach, but I thought I'd have to throw it up there just to show you that there's nothing fancy. Same for Tidy. Of course, Clang format after Tidy. clang-tidy actually makes surgical replacements, so it doesn't reformat your code like you would expect it. So running Clang format after Tidy is a useful thing. So we soon ran into limitations on this approach, and we developed this PowerShell script. It's way more complicated, much larger, very configurable, lots of working parameters, supports both compile and clang-tidy workflows, and works directly on Visual Studio project files or MS Build configuration files. So there's no conversion or round-tripping in transforming MS Build configuration or Visual Studio projects into Clang compilation JSON database or anything like that. So it works directly on your property sheets and project files. It supports parallel compilation, precompiled headers, automatically extracts all the settings from your Visual Studio configurations, preprocessor definitions, platform toolset, SDK versions, include directories, PCH information, lots of other stuff. Some switches, as I told you, it has lots more command line switches than this. These are some of the basic ones. Familiar PowerShell syntax for who's worked with that before. But this main script we basically developed for automation, and we consider it a little difficult to use, has too many knobs. So we developed something we call a bootstrapper script that it's much easier to use and calls the other script. And this is where you can intervene and customize this Bootstrapper script with custom configurations for your project or your team. An example usage of the Bootstrapper script would be, for example, -parallel runs compile on all your projects in the current directory, just scans for your project files. For example, -parallel project ignores a list of projects from the current directory, or clang-tidy fix workflow that runs all the modernized modules on projects foo and bar, ignoring files that match a given pattern. This is how it would look like, the Bootstrapper script. We provide an example. You can customize it. You can ignore it. You can put your own project-specific configurations up there. We consider the best combination or the best workflow for this PowerShell script to be continuous integration. I'm going to give you a Jenkins example here because this is what we use, but you can easily use it in some other continuous integration server that you have. For example, for Jenkins, you just need to install the PowerShell plugin. If it's not already on your box, it's available in the Jenkins gallery. That's a standard PowerShell plugin. This is the plugin. And depending on your preference, you can create a new job for Clang builds. This is what we do. Or attach a new build step to your existing build jobs. We consider this a very important issue, continuous integration, because developers on the team don't constantly run Clang compiles on their modifications. If they see their code compiles fine with Visual Studio, they will just commit the changes. So it's easy to accumulate regressions and break your Clang build if you do not build constantly to trigger alarms when something breaks. This is how a build PowerShell step would look like. You just reference the PowerShell script and tell it to compile everything. In this case, I chose to ignore a given third-party project that doesn't run on Clang, doesn't compile with Clang. We recommend that you use the workflow of building every SCM change with Clang, so that you detect very early on when you have issues with your commits. So Jenkins has this poll SCM configuration to check if a new change arrives and build it with Clang. And because the C++ community loves Slack, we love it too. When a Clang build is broken, we actually have a Slack bot that delivers a notification in a custom channel. And developers see that and take action right away. You can use a more traditional email notification system as well and see when you have a build failure on your Clang build with, of course, details of the compilation error or warning that was issued. And, of course, the author to blame. What about developer workflow? We consider the script to be acceptable as a developer workflow, but we live in Visual Studio, and we consider it to be a good environment to work in, and we want the whole experience right there in the IDE. That's why we developed this PowerShell extension, this Visual Studio extension. You just need to search the online gallery for Clang, and the top hit will be Clang Power Tools, and install it. It does require that you have the standard LLVM distribution for Windows installed. It will work with 3.9.1, 4.0.1, 5.0, so anything you need, but you need to install that standard distro. Yes, it's configurable in the standard way. You just search the tools options, and you have a standard configuration panel for the extension. You can configure its behavior, diagnostics mode, projects to ignore, if it is a solution, compilation flags. We provide good defaults that we consider have worked well for us, but we're aware that you're not going to be able to start with WAL right away, so you can disable warnings that are problematic until you fix them, and you can customize that to your project needs. You can configure clang-tidy checks right within the IDE. You can toggle specific checks. You can use wildcard checks to enable a whole class of warnings. For example, you want to enable all modernize modules, or all performance or readability checks, or you want to run certain static analysis passes. We also provide handy inline documentation for each tidy check that we pulled off the internet, so you don't have to fire up your browser and look it up. You can run it on your whole solution. You can run it on a specific project. You can run it on a single file, so on a single source file in your solution, or on several files in your solution. It's right there in all the places you would expect. Tab bars, the solution explorer. We do have a handy toolbar. And Clang compilation errors and warnings are in the place you would expect in Visual Studio, the error panel and the output window, as well as clang-tidy analyzer reports. For example, here we have a null dereference report in a source file with all the details right in place. Of course, you can run clang-tidy. There are clang-tidy checks that have auto-fixes, and for that, you can opt in to perform those auto-fixes automatically. There's a switch for that, and they will be automatically applied and reloaded in your Visual Studio environment. Or you can choose to just see the report with a suggested fix and explore that in the output window, and selectively apply each fix that you consider useful. Where can I get it? Well, there's the Visual Studio extension. We have a new site up running, clangpowertools.com. The extension is freely available in the Visual Studio Marketplace. The PowerShell scripts are available in GitHub. We do ask you to get involved if you care, and if you start adopting this for your projects and team. That is the GitHub repository. Please submit issues and bugs, give us feedback, make pull requests, suggest improvements and features. We're more than happy to listen to you. We've been very impressed by the warm feedback that we've received and the reception in the community. People have started using the tool very early on, discovered lots of problems and bugs, and suggested improvements, and we've been working hard on those to improve the tool. We thought we had complicated configuration files for our projects, but other people have much more interesting configurations. So it's always a surprise when you develop something and you think it's working for you, and you put it out there, and people start finding all kinds of crazy scenarios justified for them, and you're just going to scratch your head and say, I never thought about that. So we did fix a lot of issues. We were pleasantly surprised by people eager to contribute, and we have actually had pull requests and suggestions, and people sending us project files that didn't work for them, or some custom Visual Studio property sheets with some custom configuration scenario. And they were very eager to help us and help us debug issues. Sometimes we made fixes we were not sure about, and we had to round-trip updates to them and They confirmed the fixes for us in some scenarios when we couldn't reproduce some kind of issue. So we were very happily surprised by the community reception we've had. But we encourage that more people get involved if this is something they consider important for them. We've had several issues. I want to see those numbers go up. Please start the project and to get updates when we develop the tool further. Or submit bugs. Feel free to give us as many details as you can. Beyond clang-tidy, we wrote custom tools for our needs. These are more like project-specific. Some of the tools we developed can be generalized, and we do plan to share more tools that we develop internally with the community, like custom checks or custom refactorings. But most of the things we've done in this area are very project-specific. For example, we fixed hundreds of member initializers lists. This one can be generalized, and we could upstream this. We removed lots of class private fields that were unused, references and pointers, and scalar types. We refactored some heavily used class constructors. We changed some of our mechanisms for acquiring references to dependencies, and this required large-scale refactorings that we performed using lib tooling. So this is beyond the scope of the extension for Visual Studio, but this is something of an inspiration for you guys to develop something similar. We think the big tipping point was achieving Clang compatibility. So as long as we achieve that, and you can do it for your projects as well, even if you're not enabling all the warnings, you unlock a tremendous possibility of doing code transformations. So basically, you unlock a tremendous potential in leveraging all this goodness in the Clang universe. And with lib tooling, you have access to complete AST, and you can leverage existing tools, existing refactoring tools, like renaming tools, or you can write your own transformations. So the big step that you have to do, the leap, or you have to make your code base compile under Clang. So that's the first milestone. After that, what workflow you developed is very specific to your needs and your priorities. For our roadmap, we do work on WExtra, a few remaining issues in our code. We do plan to support this extension going forward and keep it available for the community for free. We do plan to run more clang-tidy checks, run more static analysis on our source code, and find latent, subtle bugs that our test coverage doesn't uncover. We do plan to rerun previous checks for new code and do more project-specific code transformations that we have planned. We're happy with the success so far. 40 days and counting, we have over 5,000 installs. So people installed it and are happy with it. We want to give you a big thank you to all of our early adopters for their feedback and bug reports. It's going good. Adoption for the tool is very good. We're gaining over 1,000 installs a week now. So we're very happy with the community adoption, and we would like if more people would get involved and contribute to the tool. Right now, we're the principal maintainers of this project, but we would love if more people would get involved and contribute to our repository. As is the case with such a case study talk, I guess you have your own reservations or your own doubts and questions on how you would approach this thing if you find it appealing. How would you approach this technically? How would you pitch this thing to your team lead or your project manager? So if you're interested in something like a return of investment or some kind of metric that will assure your manager that this is something worth pursuing, I cannot give you hard numbers. Sorry to disappoint. But I think a very good metric for us, at least, is that our developers are happy with it. Our developers are happy that they are able to work on a modern code base now. They are happy that they can run static analysis on their code to find subtle bugs that they haven't figured out yet. They're happy to be leveraging tools and not have tool envy. I know I had every time I went to some conference and saw some Clang talk. I was very jealous of their analyzers and their tools, so I had some tool envy there. So Visual Studio is improving with each version, and we think it's a great IDE, and we do use its refactoring abilities and its static analyzer and its ever-growing support for CPP core guideline checks. But we think these tools are complementary. It's good that you can leverage your favorite tool and get as accurate result as you can, and filter down false positives and work through your issues. So, as I might imagine that you have lots of questions and you're curious about how we approached it from different angles, I want to give you guys some ample time for questions. So if you can line up for the mics, I'll be happy to answer any of your questions. Thank you.
I'd like to start by saying it's really inspiring to hear a talk like that from a small company that's been able to demonstrate success, because it's not unusual to hear companies of Google scale talking about such amazing work. So this gives me hope, basically, for smaller organizations.
Yeah.
I'm intrigued about how you got over the very first step. Where was the motivation to start the work? Was it one person, a whole team, a manager?
Yeah. Thank you for the question. I've got that question before. So it started as a hobby project for myself. So like I said, I was very jealous and attending conferences. People were talking about their snazzy Clang tools and things they developed, and I was very jealous and curious, and I was happy to see finally a working LLVM distribution for Windows. We have no contribution in that. That's the merit of the LLVM community and the Clang community, that they've ported most of the stuff to Windows as well. So I was very happy to see a working LLVM distribution. That it was 3.9 at that time, and I just started messing with it. Let's see how it works. Let me try compile some core library with it from our code base. Get a feel for it, to learn how to use the tools. So it started out of pure curiosity for myself. And the interesting thing is, as I started fixing obvious warnings and issues, I started to commit those changes to the main repository. People on the team got interested. They saw my changes and they were curious. How did you find that bug? How did you discover that warning? I didn't see that warning in Visual Studio. I didn't know that was a bug. How did you find that? So they just got curious. And I explained what I'm trying to do. I showed them my primitive batch files. So my friend Gabriel, who's sitting over there, was one of the first persons who got involved and was curious and very happy to help. So he got interested and he developed the PowerShell script. And we both started working on it and fixing more issues and improving the script. And more people got curious, what are those guys doing? So at the same time, as I told you, we kept developing and improving on the features of our commercial product. So this was like a 20% effort kind of hobby thing we were doing. And it just got traction. More people got involved, and they were happy. So, and I must say, from a management point of view, we were lucky because we were allowed this leeway in pursuing this. And I think the main benefits were developer happiness.
Yeah, a really big thank you for this great talk and for making this tool available to the community. Actually, I have two questions. First of all, you mentioned some small quirks with clang-tidy transformations. For example, that it introduces new warnings, or that some of the transformations are actually incorrect. Did you report that? Have there been improvements to clang-tidy in the meantime?
If we submitted patches to clang-tidy, you mean?
Yeah, or reported these issues at basically. For example, you mentioned that after the transformation with range-based loop, where some warnings introduced with unused variables. Did you report that? Have there been made some improvements to clang-tidy?
I must say we're guilty of that. Okay. We should actually submit issues so that they can be addressed and fixed. We've actually been pretty busy in coping with the aftermath or the changes ourselves and coming through the changes and reviewing diffs, and we were kind of busy, and at the same time I think it was too selfish to upstream those.
I was just curious about.
So yeah, the right thing to do would be to report those issues, but some of them I just shown here on the slide some trivial examples that I can put it, I can fit it on a slide, but some of the issues were more complex in terms of dependencies, and it's more difficult to submit bugs without actually submitting your source code to their issue tracker. So yeah, it's not a good excuse. Some issues we can definitely report, but I think we've been too selfish and preoccupied with the changes ourselves. So yeah. Definitely something we should do.
I can totally understand it.
The second question? My
second question is more from an organizational point of view. If you want to do such a transformation to your code base, which affects the whole code base, and I don't know how much developers you have, how they're organized in separate teams, or whatever. There's always a discussion, do I organize a power team which does all the things, and or do I try to get all developers involved first? Can you give some ideas how you approached it? I think you gave some information already, and what your reasoning was behind that.
In terms of, if I get the question correctly, in terms of making changes that affect many components and many team members, yes, there were some changes that affected more people. We didn't actually perform many transformations that affected the public API of some of our foundational classes, so that many components were affected. So very few transformations. The one that I mentioned with the constructors that were heavily used, and we changed the acquisition mechanism for references and pointers on those constructors. Yes, those were big, impactful changes on the whole team. But most of the changes are at CPP level file, so more like implementation details, and don't ripple out to other teams and affect them. But one issue we did encounter, because we decided to do all these transformations on the master branch, so on our trunk. And I think this was a good decision, because if we have made this on a separate branch, like an experimental endeavor, that branch would quickly gone out of sync, and we would have nightmares in pulling all the changes from the master branch and doing all the transformations there. And reintegrating that experimenting branch would be basically a nightmare. So I think we did we decided early on to do this on our master branch, and I think it was a good decision. We did have issues with people developing on feature branches. So basically, when they reintegrated those feature branches, they had merge conflicts with some of the transformations we've performed. Happily, one thing that helps with this clang-tidy workflow is the fact that we all agree on the formatting, because we use Clang format. That's a big help in merging stuff. And after tidy, we always run Clang format. So, but we did have merge conflicts with feature branches, and the strategy we adopted was they should keep their changes, and we reran our tidy checks over those changes. So basically, the important code that comes from the feature branch, we accept that over the merge conflict that has a priority, and we just rerun our PowerShell script over that and reapply those checks on the new source code. So that's a workflow that worked for us. I wouldn't say it's super smooth, but it works.
Yeah, thanks for the great talk and also for the great tools. I was wondering if when you were trying to originally get everything to build with Clang, you run into any difficulties with third-party headers preventing the build, and if so, how you addressed them? For sure.
Right from the start, we do use some third-party libraries. So we cannot change their source code without actually contributing those changes. Some of their libraries we cannot even touch. So for sure, some projects we completely ignore when we build with Clang. So that's why we have project ignore, file ignore, and stuff like that. So for starters, we ignore whole projects, third-party projects. And for projects that we statically linked against and we have source code mixed with ours, I think this is something we're referring to. Unfortunately, dealing with headers and clang-tidy and Clang in general is a difficult issue, because you cannot, without actually changing code with pragmas, you cannot control the warnings that come from that header. All headers that are marked as system headers, warnings are suppressed, but that functionality, it's not on feature parity with how it works on Linux and other operating systems for Clang. But in terms of third-party headers, you basically just have to minimize their impact. Avoid including third-party headers in your headers. Use them in your source files. And if you can reduce the scope of those headers to small source files, you can ignore just those source files. For example, if you have a source file that pollutes with tons of warnings from a third-party header, just ignore that source file. The granularity level for Clang and clang-tidy in ignoring stuff is at file level with our tool as well, except for using pragmas. If you can afford using pragmas and sprinkling pragmas for ignoring certain errors in your source code, that's an acceptable thing for you. You can definitely do surgical stuff, ignoring regions of a file. But if that's not an option for you, you just have to be able to ignore single source files. That's when you see the flag file ignore in the PowerShell script or in the Visual Studio extension, that refers to a CPP file, unfortunately, not a header file. So you just kind of have to figure out what's the best thing you can do. If you can, I would actually suggest that you use third-party headers just in your implementation. Avoid using them in headers at all if possible. I know it's not always possible, but...
Oh, okay, thank you.
On your CI job, is that just a syntax check, or are you actually building an executable?
Good question. I haven't been clear on that. We're just using F syntax only for Clang, so we're just leveraging the front end of the compiler. We're not interested in pursuing compilation and link with Clang under Windows. We're happy with Visual Studio toolchain when we plan to continue building our product with Visual Studio 2017. And we have no current plans and switching to Clang LLVM toolset. So our PowerShell script and our Visual Studio extension, when I say compile, is just syntax only. So no link at all. No output.
The other question. Excuse me, the other question I had was,
Sure.
When you were trying to get things to compile, were you changing your code or were you changing Clang? Like,
No,
are you teaching Clang about, Windows-specific macros and such?
100% of the time it was our fault. so I can, for definitely sure, 100% of the time, people were using custom extensions, non-standard conformant extensions. So we just fixed those. Yeah, we were not able to do that at once. So we didn't start with WAll. We're on WAll right now, but we suppressed a whole lot of warnings at the beginning. So there's an issue. Some code transformations, they're very mechanical and have a big impact. It's very tedious to do by hand. So we actually wanted to leverage clang-tidy itself to do some of the conformance transformation. So it's like a catch-22 kind of thing. So in order to do that, we had to use, to suppress a whole class of warnings that were in the way to be able to use clang-tidy to suppress other warnings. And we gradually, yeah, it's an inception kind of thing. So, as soon as we fixed the class of warnings, we re-enabled that warning and we rinse and repeat. So,
yeah, about these extensions, I noticed that in a very early slide, when you invoke Clang from the command line, you specified delayed template parsing, and later on during the talk, with the GUI from your tools, you didn't specify that.
Yeah.
So is there any help getting rid of delayed template parsing from any tools, or did you do that all by hand?
That's a good question. I would start by telling you that, first of all, we're using the GCC driver for Clang. So we're using Clang++. There's another driver specific for Windows. clang-cl.exe, the LLVM community that maintains the Windows version of Clang built that special driver. That one, we actually have issue request on GitHub to leverage that driver as well. That driver uses several compatibility flags built in to deal with Microsoft-specific issues. I can give you some examples. Aside from delayed template parsing, handling preprocessor macros, the rules for handling preprocessor macros are different between Visual Studio and Clang or GCC. So there's a flag to emulate. Clang does a very good job on Windows in emulating, when you specify that flag, in emulating the preprocessor behavior of Visual Studio. And other Microsoft-specific issues that you might encounter. So if you're interested in not bothering at all with compatibility flags, maybe a good thing for you is to use the Windows-specific driver for Clang, so clang-cl, that enables all the right flags so that you don't have any surprises on Windows. But we chose a different route. We chose the GCC driver, so the Clang++, because we wanted to have control over those warnings and enable them and disable them as we pleased. For example, with delayed template parsing. So we did experiment. Initially, like you said, we were a little bit paranoid, and we just flipped all those Microsoft-specific compatibility switches so that we can move on. And as we improved our code, we gradually removed switches that we considered unnecessary anymore. So. But there are some issues. For example, if you're stuck on some older version of Windows SDK, SDK versions are not live updated. So if you're stuck on Windows SDK 7.1 or some older version of Windows 10 SDK, those versions are not C++ standard conformant, and they're never going to be. So the last Fall Creators Update Windows 10 SDK version, it's clean, so we can cleanly compile it. Every header is standard conformant, at least from our experience. So you toggle those compatibility flags as you need. Did I answer your question?
Yeah. Part of the question was, for this compatibility flags, is there any tooling help to get rid of them? So like clang-tidy, modernize thing?
No. Unfortunately,
so you
no.
have to do everything by hand for these
yes.
problems.
As far as I know, maybe there are some custom forks or something that I'm not aware of, but the standard standard repo doesn't have any tidy transformations to get rid of Microsoft-specific issues in your source code. No.
Okay. Yeah. Thanks.
So thank you for this wonderful tool. I'm eager to use it already, and
cool.
actually already did. And I have a question. I used it only on the CPP file just to get an idea what it does and what the transformations are. So when I would apply this to the whole code base, would it also modify third-party headers, or would it leave them unmodified? So if I
I didn't catch the last part. Can you speak up a little bit?
Would it also modify third-party headers? Like if I use, for example, Qt in my application, would it also transform those headers and add
I got the question now. Okay. Very important point. It's good that you asked that question. I forgot to mention this. clang-tidy has a switch. It's called header filter. We actually use that because when you run clang-tidy on a CPP file, for example, like you said, or on a project, but it's sufficient to run it on a single CPP file, and you will observe that effect. If that CPP file includes some headers, be it directly or a transitive include, if you perform, for example, a modernize transformation and that transformation can be applied in that header file, it will be applied. So this is something that we consider desirable. So because there were some, as you might imagine, lots of inline code. So we wanted to modernize that as well. So because you cannot specify headers when you compile or invoke clang-tidy. You have to specify source files. But we did want to apply those transformations to our inline code that was in header files. So automatically, we thought this was a desirable trait to enable header filters so that it catches and transforms headers as well that are pulled by that translation unit. As a side effect, like you said, it will touch your third-party headers. If those are included by directly or indirectly by your translation unit, it will touch those as well. It doesn't know that those are untouchable headers. So you will just have to revert those changes by hand.
Okay.
Yeah. No way around that, sorry.
Thank you.
Thanks for your great talk. We have also started to look a bit into clang-tidy on a big legacy code bases and get 2,000 warnings or so. And while we are working on this many warnings, we just want to prevent new check-ins get new warnings. So on one hand side, 2,000 warnings, we don't get the 2001 warning, but how to don't turn off warnings to get the number small while working on it and prevent new submits to introduce new issues which are just turned on. Do you have any idea of how to manage this?
I can come up with two possible strategies. One is achievable right now. One is something that you need to make a issue on. So one strategy would be to have those compilation flags that you saw in the configuration file, have those work on a per file basis, not at project level or global level. But that's something we don't support right now. Another thing that you can do right away is that you can suppress all the warnings that are in the way for the existing code base and just run the PowerShell script on the new files that come in. I'm guessing the new files are actually new files. If we're talking about new changes in old files, that's something I don't have a solution for. So, except for pragmas. If you're willing to sprinkle your code with pragmas in ignoring specific warnings, you can certainly do that. There are specific pragmas for Clang, just as for Visual Studio. If you're willing to sprinkle your code with pragmas, that will work, but that's something that not many people desire, so, as you might imagine. So, but you can definitely, if you're talking about new source files, new code that comes in new files, you can definitely use the continuous integration workflow and call the PowerShell script with all the warnings enabled on new code, and call it with warnings disabled on your existing code. So you can mix and match. As I shown you the Jenkins integration, you can easily do pre-commit hooks, for example, to run our PowerShell scripts, or poll SCM changes, and actually, Jenkins is very configurable in this area. It can actually tell you what files changed and apply a different command line script just for those files. So you can mess with this via your continuous integration server, or in your source control management system as pre-commit checks or something like that. But if you're doing changes in an existing file, you're stuck with pragmas.
Okay.
Sorry.
Thank you.
Go ahead.
Hi, I have a question about the checks configuration. Do you support as input the clang-tidy file or not? The clang-tidy file as input for...
let me just show you. Yeah, we have you can use custom. You're referring to wildcard checks, right?
Yes, or either an input file. My idea is to configure this per project, and to be able to configure the checks at project level. So usually on a Linux world, it looks for the clang-tidy file, and it reads the configurations from this file.
Ah, okay. So it's a project-specific clang-tidy config file.
Yes.
We don't have support for that right now. This is something we could do if you make a feature request on it.
Okay.
Please do make a feature request on GitHub.
Okay.
So,
okay. Thank you.
Never thought about that. So it's a good suggestion.
Yes. Okay. Thank you.
Thank you, everyone. I've been informed that the session is over. You can catch me on the hallways. If you have more questions, I'll be happy to answer them. I'll be here all day. Thank you very much.